So if, for example, you have something like this, 2 cosine t 7/6. So what is the period? Is this periodic? Is this periodic? Can somebody answer, please? Hello?
It's a periodic, sir.
Why? Why is it periodic?
It's a rational number, sir.
No, that is not the answer. There's only one frequency here. There's only one sinusoidal signal here. So it must be periodic, right? This is only
Yes,
cosine.
sir.
This is the only signal. There's only one signal here, which is periodic. Cosine, sine is periodic, right? Right or not? There's only one signal here.
Yes, sir.
Cosine. There's only one signal here. Okay, it's going to be periodic. I mean, just a very rough drawing. So there's one signal here with the period t. There's no other signals here. And then the period t is looking at here. This is omega, isn't it? Omega t.
Yes,
So
sir.
whichever things that's multiplied with the t is omega. So t is 2 pi. Seven over 6. Is this right? T is okay. So what is the period? So it's going to be 2 pi times 6 over 7. So the period is going to be 12 pi over 7. It doesn't matter it's rational or not. Even though if it's irrational, we only talk about rational, irrational when we are comparing two different signals. There's only signal here, there's only one signal here, and a sinusoidal. Therefore, it must have one frequency. If there's a frequency, there should be a period. Is that clear?
Yes.
Yes, sir.
The moment you see this, you should know it's periodic. How about 1 now? If I plus 1, is this periodic? This is periodic. If I add 1, is this periodic?
It's not a periodic table. Actually, periodic table, but it's not periodic, sir.
Why?
Two signals are produced, sir.
One signal is AC, the other signal is DC, right? One signal
Yes, sir.
is AC. Now you add another signal, and this is simply a DC. Why it cannot be periodic? If you add them up, what do you get? You get a signal that's offset.
Cutoff frequency, sir.
Same frequency, same cosine, but it's offset by 1. Okay? It's still periodic. If this is periodic, okay. This is periodic. This is periodic.
No, sir. No,
Why?
sir.
This is periodic. Yes, periodic. This is why no. Why only G answering? What about the other guys? Kavin, Geethan. Geethan, are you around?
Sir.
Kavin,
Yes, sir.
you guys logged in and then you went back to sleep, right?
Sir, no, sir.
Okay, relax, relax. I'm just joking. Okay.
Yes.
Okay, is this periodic or not? Geethan? Just
Yes, sir. Yes, sir.
periodic. Why do you say that? If you're not sure, guys, all you have to do is sketch it. If you're not sure, okay, this is the original signal, right? This is this part here. Now you're adding what? What is T? T is a ramp signal, ramp, ramp. It's just like, having xt, let's say, for example, xt is equals to t. This is t axis, and then it's just going to be a ramp. Just like y is equal to x, you remember? It should be just a y is equal to x, something like this. So a t we get a ramp signal. The tsunami wave starts, then if we end up with a ramp signal, it's going to the coronavirus signal. If it's ramp, then you're gone, man. Right now, coronavirus signal is going like this, right? So
Yes,
if you
sir.
get a ramp, what happens? It will wipe you out from day one. So we have exponential signal. This is a ramp signal. We still don't know what is a ramp signal. This is T, okay? And they say you are varying T from 0, 1, 2, 3, and 4. So you're going to also get xt. Input value, this is the output value. Input, let's say xt is t. You vary t from 0 to infinity. You're also going to get the output that varies from 0 to infinity. If you plot that, you're going to get a ramp. 1, 1, 2, 2. Do you guys understand? These are the basic in signal systems. If you're not sure, you should sketch them out and see. So what happens if you add these two signals? Which one will win? One is not periodic. This is periodic. This is not periodic. Which one is going to win?
Non-periodic.
Yes. So what will happen is this periodic signal is going to write on the non-periodic signal. This periodic signal is going to do this. It's going to start writing on this and going to infinity. So the net result is you have an oscillating signal that's growing to infinity. Okay, this is not periodic. Same thing, if you have an exponential signal, anytime you mix with a growing signal, it's going to be non-periodic. Now I'd say sine 3 over 2t plus cosine 6 over 4t. Okay, is this periodic or no? Is this periodic?
Yes,
Why periodic?
because
Say sign lah. Why?
because didn't have different angle.
Different angle. Where got angle?
No, I mean it's like it's overlapping
This is
only.
frequency. So this frequency, say call this frequency 1 and this is frequency 2. Is frequency 1 equals to frequency 2?
Yeah.
And both of them are same, 3/2
Yes.
radians per second. So you same signal, but because they forgot to simplify this, 6/4 is 3/2. It's the same signal, but students are finding two different periods. Why are they doing that? I don't know. We can simply say yes, it's a sinusoidal. Both of them are same frequency. Therefore, they must simply add up or overlap. If this is 2, they're going to overlap and make the amplitude 3. Sorry, okay. So periodic. Let's say you have another signal. J 10 plus e to the minus j10 divided by 2. Is this periodic? Okay, let's try one by one. This is omega 1, isn't it? This is omega 1. So omega 2, from the Euler series, you know that this is cosine 10t. From Euler identity, you know this is cosine 10t. Omega 2 is equals to 10. So T1 is equals to what? Omega 1 over 2 pi is 3 over 2 pi. T2 is omega 2 over 2 pi is equals to 10 over 2 pi. Then T1 over T2 T1 3 over 2 pi divided by T2, 2 pi over 10 is 3 over 10, a rational number. Rational number. Therefore, it's periodic. Period, you simply cross multiply. T1 over T2 is equals to 3 over 2. This cross multiply. The period is either 2T1 or 3T2. Let's say if I'm using 2T1, then T1 was calculated to be 3 over 2 pi, right? Which is same as 3. T2 is 10 over 2 pi. Okay, 3 times 2, 6, 3 over 2. Are they giving the same? This is a 3, 6 over 2 pi.
Not same.
Very, pardon?
Not same, right?
Not the same. Then something is wrong somewhere. Let me see. Omega 1 over 2 pi. The other one is 10 over 2 pi. T1 over T2. Oh, so that's a problem here. This is 3 over 10.
3 over 10, sir, over there.
So that's why it's not working. So cross multiply now becomes 10 T1 is 3 T2. So 10 T1 and now it's the same, right?
Yes, sir.
So now you cancel, you get 5 times 10 over 2 is 5, 5 times 3, 15, 15 over, so that's a period. It's a period in seconds. And it's also periodic. So when you say periodic, get this very clear in your mind, you know, when you say periodic, you also must calculate the period. Okay, this is a very short homework, very easy homework I have given you. Please, if you just send me some nonsense, I'm going to just give you 0. That's it.
Sir,
Huh?
supposed to be T equal to 2 pi over W, omega, am I right?
Did I make a mistake here?
T equal to 2 pi over omega, am I right? Supposed to be.
I think so, yeah. Yeah, right. You mean T is omega over 2 pi. Like this, you mean?
2 pi over omega, sir.
2 pi over omega.
Yes, sir.
And now only you say yes, sir. A lot of you go ahead and continue to sleep in this class. Good for you. So I'm making mistake here, you know, and people are not helping me. In the end of the semester, you come and complain. The lecturer not teaching you properly. Two pi over 3. 2 pi over 10. So 2 pi over 3 multiplied by 10 over 2 pi. So this is a big blunder. Supposed to be 10/3. But we put 3/10. If you're a rocket science engineer, the rocket is going to go the other way.
Sir, for T2,
Yes.
for T2, can we simplify as pi divided by 5? Can we?
T2.
Yeah, can we
Can.
do that?
Can also. Same thing. You get the same answer also, right? 3T1, 2 pi over 3 is equals to 10 T2, 2 pi over 10. So both are giving you the period to be 2 pi. This is a fundamental period. Okay, let's do. Yes.
If the answer is irrational number, that means if the signal is not periodic, am I right?
Right.
Okay, sir.
If this is this is rational. Okay. There is a rational number. So therefore, this is periodic. Is equals to cosine cosine. My stomach is burning. Okay. Cosine 4 pi t plus sine 6 pi t plus e to the j 5 pi t. Right. So call this omega 1. Okay, the frequency is here. Pi omega t. Okay, again, T1 is difficult to get this confused. So T2 pi over omega 1 is 2 pi over 4 pi is 1 over 2. Period 2 is 2 pi over omega 2, 6 pi is 1 over 3. T3 is 2 pi over 5 pi is 2 over 5. Is it correct so far? Let's try to do without mistakes.
Yes, sir.
3 over 2, 5 over 4. Okay, let me see, 1 over 2. Okay, 1 over 3, 2 over 5. Now we want to compare one by one. It depends on which one you want to compare. You can compare with this And then you also can compare with this. So let's try T1 over T2. T1 is 1/2, T2 is 1/3. So that's going to give you 3/2. Next, you want to compare T1 with T3. And 2/5 is equals to 5/1. Okay. So those are both rational numbers. If you see,
Is it T1 or T3 is 5/4?
5/4. Yes, 5/4. Thank you. Thank you. 2/5. So T1 over T2 is 3/2. T1 over T3 is 5/4. Both ratios of integers. So rational numbers. Therefore, it is periodic. Now, how do you find the period? So to find the period, you have to take these two ratios and you compare them 3/2, and then let's say, and then you are having 5/4. So then you have to come and look for the LCM of the denominators. LCM, I'm not adding, I'm sorry, it's not adding, I'm just comparing these two. You take the LCM of the denominator. LCM, which is the one number where both numbers can go through. LCM of denominators LCM of denominators is equals to 4 times 2, 8. So therefore the period is T, period T, sometimes they call T naught. So the period T is simply LCM times by T1. Because T1 is the main thing, you're comparing T1, yeah, and you're using the T1 as your reference. Just follow these steps. You will be okay, okay. If you want, I can give you some problems for exercise. Anybody want?
No.
Okay, thank you. You don't want to do any work. You guys just make me slave away. T1. So that's going to give you 4. So therefore period is 4 seconds. You guys have enough, or you want more example on this?
Now for today.
Huh?
Enough for today, sir.
Enough.
Okay.
Did everybody agree with that? JJ,
Yes,
you said
sir.
enough also, right?
Huh?
JJ, you said enough, is it? Why is such a difficult decision to make? Okay, I think it's very shy to say that. So,
sir,
okay. Huh?
question.
I think,
I have a question. So
Mhm.
if I put t equal to 8t2 or 8t3, is it correct?
It won't be correct because your T1 is the reference here. If you want to know, you can try this. If you want to put 8T2, then you have to do this. You want to do this T2 or T1 and then T2 or T3.
Oh.
You can try it. You can get the same answer.
Okay, sir. Got it.
Huh?
Got it, sir.
So why, just keep it T1, the first one. It'll be easy to remember. So why don't I give you a small exercise for you all to just, no need to submit, just practice.
Okay, sir.
Are you sure?
Sure, sir.
For practice. If you get the answer, you want to WhatsApp in the group, everybody want to see, or you just want to keep it to yourself, and that's fine with me. It's cosine 4 pi plus sine 6 pi t plus cosine 5t. For practice. Periodic. If yes, next time we do more problems on energy. Okay. Okay, guys.
Okay, sir.
Thank you very much for coming and listening.
Yes, sir.
Okay, sir.
Sure, sir.
Okay, sir.
Thank you. Bye.
Bye, sir.
Okay, bye, sir.
Bye, sir. Take care.